Hello, this is Ms. Nicholas. I'm going to teach you how to simplify rational exponents. These are notes 3.2. So now you see exponent rules refresh the table, and first rule is product rule. Product rule we can apply when we have same base. In this case I have same base A, and I have to add exponents m and n. Okay, so now let's take a look at example. I have x squared times x to the third power, which I know I can apply product rule. Same base is x, and adding 2 and 3 together, I have x to the fifth power. Next rule is our power rule, where we keep the same base and multiply exponents. Now, a good example would be x squared to the power of 3, therefore I keep the base, and 2 times 3 gives 6. Next rule is a quotient rule. I do have base A, I keep the same base, and subtract exponents. An example of quotient rule is x third divided by x squared. We keep the same base, we subtract 3 minus 2, therefore I have x to the first power, or just x. Next rule is negative exponent rule, and we don't like negative exponents. First case, a to the power of negative n is in numerator, so we can switch it to denominator, making exponent positive. In second case, a to the power of negative n is in denominator, so I can make it positive by switching into numerator, and therefore power becomes positive. Example could be 3x to the power of negative 2, so I need to make exponent positive. 3 would stay up, and x needs to go down with exponent 2. Our next rule is a zero exponent rule. Anything to the 0 power is always 1. It's an easy one. So we can look at example. Could be x squared to the power 0. It's 1. Last rule is switching between exponents and radicals. Here we have a square root of a, so we know if no index is written, it's 2, and I know a is the first power, therefore a is 1 over 2. So a exponent is a fraction of 1 over 2. In general form, we have a as a base, m is numerator, and n always goes on the bottom. So here we have a few examples of switching from radical form to exponential. Let's take a look at first example. We have square root of 2 and under the root 50x cubed y to the 18th power. So now if I want to switch into exponential form, I know that 50x cubed y to the power of 18 all need to be raised to exponent power 1 over 2, which means that I have to distribute the exponent 1 over 2 to all of the members in those parentheses. So 50 is with the power 1 over 2, x is the same thing, but I can multiply it out of y. 3 times 1 is 3 over 2, and y, 18 times 1 over 2. So what I have is 50 with exponent 1 over 2, x with 3 over 2, and y, I can divide 18 by 2, which is 9. In our next example, we have a mix of radicals, and fraction exponents. So let's switch it into exponential form. So here we have 128, and I know that cube root is going to be 1 over 3. I have everything in parentheses, and that's everything raised to the 7 over 4 power. Now, next one, here I have 64, also raised to the power of 1 over 3, and outside parentheses I also have power of 3 over 2. Okay, now we can apply a power rule, which means I'm going to multiply my exponents. 1 times 7 is 7, and 3 times 4, I have 12 as my denominator, times 64, and here I can simplify. So 64 is to the power of 1 over 2. Now when we look at our bases here, 128 and 64, we know they are even numbers, and let's take a look. They might be binary numbers, which means I need to just look at the side note. Okay, 2 to the first power is 2, 2 to the second power is 4, 2 to the third is 8, 2 to the fourth, 16, 2 to the fifth, 32, 2 to the sixth, 64, 2 to the seventh is 128. I'm not going to go on because it seems like here we go. We have to use 2 to the sixth power and 2 to the seventh power. So now instead of 128, I'm going to use 2 to the seventh, and it's raised to the power of 7 over 12. Now next, 64, I'm switching to be 2 to the power of 6. Once again, power 1 over 2 stays. So now next thing, I have to multiply the powers, which means 7 times 7, it's 49 over 12 times 2. I can simplify here a bit. 6 times 1 is 6 divided by 2, so power here is 3. Next thing, I can apply product rule, which means that base stays the same. It's 2, and I need to add exponents. So 49 over 12, we need to add 3. Therefore, we need a common denominator, so I'm going to multiply 3 by 12. So next is 2 to the power 49 over 12, and then I add 3 times 12 is 36. Therefore, exponent comes out to be 49 add 36 is 85 over 12. My final answer with not such a nice exponent. In the next box, we see 2 examples. So here I need to switch from radical form to exponential. I know that this square root has index of 2. Therefore, my second x, I know exponent going to be 3 over 2. I know index always goes into denominator. Now I need to use product rules to add exponents. This x with no exponent was to the first power, so now let's add it. 1 add 3 over 2. Common denominator is 2, so let's multiply this by 2. So my answer here is 1 times 2 is 2, plus 3 is 5 over 2. Okay, let's move to next example. Here I have square root of k raised to the power of 3 times cube root k to the power of 4. So let's switch into exponential form, which I'm going to have k 3 over 2 times k 4 over 3. Now here I'll have to add exponents, so I know that common denominator is 6, therefore I need to multiply this fraction by 3 and this fraction by 2. So I have 9, add 8, which is 17. Last example that I'm going to show you here is where we're going to use first on the numerator side. I'm going to use here power rule. So x -2 times 2 is -4. Also in denominator side, I'm going to use the same power rule first. So 1/4 times 4, I know that would cancel out the 4's, so x is to the first power here. And now we're going to use quotient rule and subtract exponents. -4 minus 1, so we have x to the power of -5. However, we don't like negative exponents in the answer, therefore we have to switch it to the fraction 1 over x to the power of 5. To finish your notes, make sure you answer the question below this example, which is how to switch cube root of a to the 5th power from radical form to exponential. Thank you.